Hello everyone, Mr. Boltri here bringing you video 1.4 in which we're going to be talking about tables and graphs. So today in class we conducted the circles lab, and as I was looking at your data that you collected in class, I noticed that some groups data looks something like this and some groups data looks something like this. So the first thing I wanted to talk about is how to collect data using a table, and the person on the right has collected data using a table. And I want to talk about how to use tables and why they're important. So the first thing I wanted to mention is the benefits of using a table. And I can think of several benefits of using a table. First, it makes it easier to collect your data because you know exactly what you need to measure and exactly how you need to measure it. And you can just plop it right into your data table. You don't have to look around for where do I put the data and what am I measuring again. So it just makes it easier to run a really good experiment. It also makes it easier to graph your data because if you go to graph it, then you have your XY data point right there, and you don't have to try to figure out, wait, which one is which, and sometimes mix them up. And then last but not least, it makes it easier to share your data because it's a lot easier for someone to look at this data table and know what the group did versus the other collection of data and know what the group was doing. So those are just three of the reasons why it's beneficial to use a table. Now I want to talk you through how to use a table using an example of my cat, whose name is Echo. So when we got her, which I'll just say is 0 months, she was 1 year old at the time, but that's 0 months of me having her. She was really skinny. She was really underweight. And the vet told us that we wanted to get her weight up. So I've been using a table to keep track of how much she weighs over time. And just so you're not concerned, we've had her for 10 months and she's happy and healthy now. So, but I'm going to use this as an example of how you can use a table to keep track of some important data in a scientific experiment. So the first thing with how to use a table is you really want to set it up in advance. Because if you're able to set up your table in advance, you know exactly what data you need to collect over the course of your lab. If you're not able to set up your table in advance, that's probably indicative. It probably means that you don't have a really good idea of how you want to run your lab because you don't even know what data you want to collect. So setting up your data table in advance really helps you run a clean lab, and it helps you make sure that you're on the same page with your partners about what you want to collect and how you want to collect. So as you're setting it up, you want to label each column with the what you want to measure. In this situation, I'm keeping track of Echo's weight over the course of several months of me having her. And even as I say that, it's important for you to include units because it would be different if I was weighing her every week or every day versus every month. And so you really need to show that in your data table. And I'll be doing the Echo's weight in kilograms just because that's the weight that the vet said her target weight was in kilograms. So I've just been trying to stick with what the vet has been using. And then last but not least, as you're collecting your data, you want to try to follow good data collection practices. So one of the things is it's really nice if this can be consistent, but it's okay if it's not. Once we graph it, it'll all work itself out. It's nice if it's consistent. It makes it easier to see patterns, but it's okay if it's not. And the most important thing I wanted to draw your attention to for good data collection practices is if you ever have a data point that you think is actually not right. You think maybe, I might have read the scale wrong. So I put Echo on the scale and I thought it said 6.2 kilograms. So I wrote that down in my lab notebook, but then I was looking back at the other data and I was like, whoa, she must have jumped up a lot in weight. So then I went back and I weighed her again and I actually just missaw, it wasn't 6.2, it was 4.2. So instead of erasing that data point or scribbling it out so nobody could see, good data collection is just to put a single line strike through and then write the actual correct data point. So I know it's tempting to just use your eraser or scribble it out so your data table looks nice and neat and clean. But that's actually, in the scientific community, that's considered to be destroying data, and it actually invalidates your experiment. So It's good to learn from our mistakes, and I made the mistake of misreading the scale. So I'm just going to do a single line strike through my incorrect reading so I can remember and learn from my mistake, and then write down the correct reading right next to it. So that's just one of the good data collection practices that I would like for you to exhibit in this class. So now we have this nice data table. The question becomes, what do we do with it? And one of the things that I always think to do with it when I see data nice like this, I kind of want to figure out, well, what's going on? Like, what's the pattern? And one of the ways to figure out the pattern of what's going on is to graph it. So now I'm going to take you through just some simple steps for how to graph your data and make sure you do it well. So first, in terms of graphing the data, is you want to include a descriptive, useful title. So some people might say weight versus time is enough of a title, but I just want a little bit more information in there. So this is Echo's weight versus time after her adoption. So just a little bit more descriptive really makes it helpful for somebody looking at the graph to know a little bit more about what's going on. Next, you always want to graph on graph paper. If you're just graphing on a piece of white paper or blank paper, you're not going to be able to accurately graph your data points. So that's why we got lab notebooks that are full of graph paper so that you always have graph paper handy for the many graphs that we're going to be doing in this course. Next is you want to label your axes with your units. So here I have time on the horizontal axis and weight on the vertical axis in months and kilograms respectively. And you'll notice that in this class, I'm going to call the two axes the horizontal axis and the vertical axis. And the reason for that is in math class, you've probably heard it called the x-axis and the y-axis. But in this class, we're not graphing x's and y's, we're graphing actual thing like time and weight. So it doesn't make sense for me to say the x-axis and the y-axis. I will call it the horizontal axis because it's like you're looking out over the horizon, and the vertical axis. But if you call it x and y, I won't be mad at you, but I might correct you just so we can start using that terminology as well. And the next most important thing is you need to use a consistent scale that fills up as much of the space as possible. So you can see here, every one of these is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which my biggest time is I think 12 months. So that uses most of the space, more than 2/3 of the space. But then it wouldn't make sense for me to use the same scale on this vertical axis because 1, 2, 3, 4, 5, 6, 7, if I went all the way up to 15, then I would only use this small area down here. So I'm using a consistent scale on the horizontal axis, a consistent scale on the vertical axis, but they don't have to be the same, which allows you to fill up the whole space. On the horizontal axis, every one of these spaces is 1. On the vertical axis, every one of these spaces looks to be 1/2. So that allows me to space out my data so that when I do graph it, it fills up the entire area. And again, super importantly, every one of these spaces has the same value. Every one of them is 1 going this way and 1/2 going up. So it's very important to be consistent and to choose a scale that allows you to fill up the entire space. And then last but not least, you carefully plot your data. So it's really easy when your data falls very nicely on one of these intersection points. It's easy to plot your data. But for example, right here, I took one of my data points at 1.5 months. So you guys, it's totally okay to have 1 be here, 2 be here, and just for us to know that 1.5 is halfway between 1 and 2. So as long as you try very carefully to get it as close as possible to right halfway in between, then all of your data points do not have to be exactly perfectly on different intersection points. It's okay for your data to be halfway between 4.5 and 5, and for us to know that this is about 4.7. So once you get all of your data carefully plotted, then in our next video, we're going to talk about how to analyze your data. And before I let you go, I wanted to talk about just some of the benefits of graphing your data. And there are a lot of them, but here are just a few. It allows you to see patterns. It allows you to notice outliers, which are data points that are different from what you might have expected them to be. It allows you to share your findings with others. It allows you to establish models, and those models allow you to make predictions. And then from those predictions, you can draw conclusions. And this is all benefits that we get when we do graph and analyze our data, which, like I said, now that we have our data graphed, in our next video, we're going to be analyzing our data. But this is Mr. Boltri, finishing up video 1.4, which has been about tables and graphs. Go Bears.